This video deals with two concepts. First of all, the concept of density. Previously, we have been working with bodies that have a series of particles. Now, imagine we get one particle or one small piece of mass, which we call the differential of mass. The density of this body is going to be the amount of mass of this particle over the volume that occupies this particle, or in other terms, density equals mass over volume. This is called the volumetric density. The units of this are kilograms for mass over the cubic meters for the volume. It could be also pounds over cubic feet or other international or English system units. Water, which we usually use, has a density of 1000 kilograms over cubic meters. The second concept we will work is pressure. Pressure is a force applied over a certain area. This concept only works in fluids, which means liquids or gases. The units in the international system are, for instance, Newton per square meters. Newton for a force, square meters for an area, and these we will call them pascals. One atmospheric pressure, one atmosphere is 1.013 times 10 to the 5 pascals. There are other units, which are the pound per square inch. This is the English system. We state them as PSI, where one atmosphere is equal to 14.7 pounds per square inch. In order to measure the pressure, for instance, the atmospheric pressure, we have an instrument that is called the barometer. The barometer is a capillary tube, this capillary tube, which has vacuum. The layers of the atmospheric air are pushing mercury into the capillary tube. So the more layers we have, the higher is going to be the height of mercury inside the capillary tube. If we are at 1 atmosphere, it means that it will increase to 70-60 millimeters of mercury. Probably you're acquainted with this kind of units because of this. A very good question is, why do we use mercury instead of other fluid? Why not water, for instance? Try to look for this answer. Another very useful device in order to measure pressure is called a manometer. Instead of trying to measure the atmospheric pressure, we're trying to measure the pressure exerted by one gas. But there is going to be a difference on pressure. This is called the manometric pressure or the gauge pressure. This difference of height, there is going to be a difference of height exerted by, for instance, the mercury, which will state there is going to be higher atmospheric pressure than the pressure in the gas. Now try to figure out, both of them are pushing, but one pushes more, which means it's going to exert a difference in height to the liquid that we are using, for instance, the mercury. That is going to be a difference in pressure, which we call the gauge pressure. In industry or in other kind of devices, such as a stationary tank or whatever, we usually use these valves, which are the manometers, and they will give us the information about how many pascals, or in this case bars, are going to have. More or less, 1 pascal is more or less 1 bar. So we have been working with the concept of density, the concept of pressure, and how to measure this pressure with a barometer and the manometer.